Hello everyone, today we'll learn how to represent a process in block diagram form. Block diagram is representation of any process in simple block and directional flow commands, that is blocks and directional flow commands. It helps in better understanding. With the help of block diagram we can represent any process in its simplest form. Now here we will learn about the key elements of a block diagram. First of all, in any process we have a plant. Here we have represent a plant. For example, we have to maintain the temperature of this plant. Now to maintaining the temperature of the plant we have to measure the temperature of the plant at that instant. That is the output. The output temperature will be measured by our measuring device. This measuring device will now send a signal to our error detector. The signal from the measuring device to the error detector is known as our measured value or the feedback value. This is the measured value, that is the temperature of this plant at that instant. Now in the error detector we have already preset our set point. For any condition we have to set a set point. For example, when we are measuring the temperature, keeping the temperature of this plant, we are having a particular set point for this particular set point of temperature for this plant. That set point we have input in the error detector. Therefore input of the set point is in the error detector. Now when the measured value goes, it will measure the deviation. That is, deviation is set point minus measured value. Set point is represented as V, measured value as P. Therefore deviation will be V minus P. Therefore at the bottom we have given negative, at the top we have given positive, as the measured value is subtracted from the set point. Now from the error detector we will send the deviation, that is the error signal, to the controlling element. Now in the controlling element it will justify how to decrease the deviation. In what process to decrease the deviation, the controlling element will act upon it and send the signal to the final control element. Final control elements are nothing but our last valves that helps in manipulating. The signal from the control element to the final control element is known as the actuating signal. Thus actuating signal is nothing but the signal that is sent from the control element to the final control element or to the process plant. In the final control element, after it's acting, there will be certain action in the plant. The deviation will decrease. Again the output will be measured, that is the temperature of that particular instant. It will be measured by the measuring device. It will send back to the error detector, where it will do the subtract from the set point, measure the deviation, send the error signal to the control element. From the controlling element it will give an actuating signal to the final control element and to the plant. This way we decrease the deviation, and this is the representation of a block diagram. Here the nomenclatures of the key features are as set point we have given as V, error signal as A, controlling element as G1, actuating signal as M, final control element as G2, and actuating signal as M. Process or the plant is represented as G3. The output from the plant is C. The device that is measured, the output is H, and the feedback signal or the measured value is represented as B. We can represent this block diagram with the help of better understanding. We can show the block diagram with the help of a home heating system. In the home heating system, we already have known the process. We have to heat up the home. For heating up the home, we have particularly set the temperature at a particular set point. We measure the temperature of the home at a particular instant with the help of a regulator. The regulator here is this one. Here this is the home. It will measure the temperature at a particular instant. This is the home and this is the regulator. After that the temperature is measured. Now here for particular action what to be done, the deviation will be measured. Here from the measuring element, we'll measure the error, the deviation, then send to the controlling element. Here is the controlling element. It will act upon it, how to do it, and send an actuating signal to this final control element. This from the controlling element to the final control element, the actuating signal this goes to the final control element. Here in home heating system is our valve. This is our final control element. This element, if the deviation is more, that is the temperature is much less than the required one, the gas will open, furnace will heat up the air more, the home will get further heated up. And again that output signal will go, it will be measured by the measuring device. The measuring device will again do the deviation signal will go to the control element. The control element will act upon it, send a signal to the valve. The signal that is gone to the valve is known as actuating signal. The valve will then operate and will decrease the deviation, and at the process the plant will maintain its temperature to our satisfied, to our desired set point. This is the simple representation of any process with the help of a block diagram. Any process, liquid flow, the tank level control, any process we can represent with the help of this simple block diagram. Thank you.